you remember dividing fractions in grade 7? Do you remember what you had to do to this guy here? This was the same as saying 2/5, and then we'd say it's times, and then you would flip it, right? You would flip this guy, right? It's just called the reciprocal. So that's 15/4. Now, check this out, because then it becomes fun. Look, 2 goes into itself once, into 4 twice, right? 5 goes into itself once, and into 15 3 times. Straight across multiply. 1 times 3 is 3. 1 times 2 is 2. There's your answer. Nicely reduced. Well, we're going to use the same idea when dividing out rationals. Oh boy, this ought to be fun. Let's take a look at this one. Now, I factored this for you to make it a little bit easier for you, but here's something I want to look at. I want to look at the NPV. Since it's already factored, I want to look at all the NPVs and state them first. Okay, let's look at this guy right here. Look, we know x cannot equal to 0. Check out for this one. X cannot equal to 0, and x plus 4 cannot equal to 0, which means x cannot equal to -4. So it's redundant to say x cannot equal to 0, x cannot equal to 0. We've said it once. That's good enough, okay? So far we're good. But don't forget that afterwards we take this guy and we flip it. That means this becomes 2x minus 8 over x times, and I'm going to use a dot instead of an x, okay, times x plus 4 over 12x minus 8. Now, if you think about that, look at this. We now have something new in the denominator. Which means, guess what? We have to state the NPVs of that as well. Well, we don't really care about the 12 because you know that 12 can never equal to 0 anyways. So we don't really care about that. So yeah, let's just yeah, it does, no, it's gone, right? But we do care about x minus 8 not equaling to 0. Bringing the 8 over, we found out, guess what? We have one more non-permissible value. And it all is because of the fact that that is reciprocated. So in other words, think about this. If we're going to look at this, how do we state the non-permissible values? We'll state the non-permissible values of that one, state the non-permissible values of this one, and this one, because after all, you're going to flip it anyways. So that's what this says right here. NPVs and division. It says find the NPVs from each denominator before the flip, and then find the NPV of the new denominator after the flip. Or you can just do it all in one shot. Figure out this guy, figure out this guy, figure out this guy, right? So figure out the NPVs. But now take a look. Everything is so beautifully set up for you. It's crazy. Watch this. You can just cancel the x minus 8s. You can cancel the x here and here. 2 goes into itself once, into 12, 6 times. So look what you have. 1 times x plus 4, so x plus 4, over, oh, the only thing that's left is 6. Look at that. That's it. That's your answer after canceling. Great. But your NPVs then are x cannot equal to 0, x cannot equal to -4, and x cannot equal to +8. So your NPVs are x cannot equal to 0, -4, and 8. And look at that. That's not that tough to solve, is it? It's just one more step, figuring out the NPVs, and of course, flip and multiply.